All right, now let's suppose we have, we're dealing with sequence and patterns, right? And let's suppose they gave you, this is figure 1, this is figure 2, this is figure 3. And they asked to draw the fourth figure. How would you go about doing this? Well, you'd have to study the pattern, right? So study the pattern and see what's happening. Right? You must be able to look and see this same figure 1 in figure 2. Where is this figure? In figure 2. It's right here. So that means they added one square there and they added another square here. Okay, now see this one. See the second figure in figure 3. Where is that? Okay, 1, 2, 3, 4, 5. So we're gonna go. See from the corner here we have 2 out, corner 2 out. So it'd be right here and down 2. All right. So this is actually right here. This one is figure 1 within figure 2, and this one here is actually figure 3 within figure 2. Sorry, within figure 3. All right, so you're seeing what I'm saying here. You're seeing this figure in this right here, and you're seeing this entire one right here. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And what did they do? They added one square. So every consecutive figure, they add one square horizontally and one square vertically. So what you'll do is to draw the previous figure first, right? To draw the previous figures. That's what they would have done here. They drew the previous figure right here and added a square here and here. They drew the previous figure here, added a square here and here. So we're going to draw the previous figure, which is figure 3. So we're going to 1, 2, 3, 4 squares. 1, 2, 3. All right, it's not going to be perfect, but since we have 1, 2, 3, 4, and we're going to go down 1, 2, 3. Okay, so this is actually figure 3. I just reconstructed this figure right here. This is figure 3. Okay, right here. And then I'm going to just simply do what? Add one square here and one square here, as they've been doing. And this is my figure 4. So that's basically the idea. Study the previous pattern and see the previous pattern within the new pattern and so forth. Okay, now here we have some patterns again, but this time numbers. And what we're going to do is look at the figure number. Okay, look at the figure number and see what happens with the figure number. Okay, so we have the figure number 1, 2, 3, 4, and so forth. All this is saying, just like when we had in the previous drawing, we see the figure 1, we saw figure 2, we saw figure 3, and so forth. But this information here is unrelated to the figures that we were looking at. So what we're going to just see how we go about doing this. Okay, 1, 2, 3, 4, the fourth figure. Notice that they skipped the fourth figure. Well, they skipped the fifth and sixth figure. Okay, so they skipped some figures here. They skipped the 5th and the 6th figure, and they go to the 7th. Then they skip the 8th and several others, perhaps. We're not sure what figure is this that would have produced this number. So figure 1, basically, guys, figure 1 has a parameter of 7 units. Figure 2 has a parameter of what? 11 units. I say units because I'm not sure if it's centimeters or whatever unit it is. Figure 3 has 15 units. And they tell us about the number of outer lines of unit length. Okay, so let's see what's happening here. Okay, so what we're going to do is to see for figure 1, there's this 1 here. For figure 2, well, figure 1, notice that we have a 3 here and then a 3 here. We're not sure what's happening yet. Okay, we notice there's figure 2, we have a 2. So I see something so far that with 1, we have a 1 here. All right, and then with 2, we have a 2 here. Then with 3, we have a 3 here. So it's obvious to me that the first number I should have here is 4. Whatever figure number it is, the first number in the sum should be 4. Then plus. Now I've noticed that while these numbers are changing, 1, 2, 3, 4, the middle number being added is constant, is fixed at 3. So I'm going to put 3 there. Now if I look at the other figure numbers, well, the other, not the figure number, but the other numbers at the end, 3, then I see 6, then I see 9. I can see it's the last number is going up by 3. That's what I noticed, right? So that tells me that since 4 comes right after 3, just like the 3 comes after 2, etc., and we keep on adding 3, then I should simply add 3 here, and I'll get 12. Okay, now let's see something here. 1 plus 3 is 4, plus 3 is 7. 2 plus 3 is 5, plus 6 is 11. 3 plus 3 is 6, plus 9 is 15. Therefore, 4 plus 3 is 7, plus 12 is 19. That's interesting. Can I pick up something here in terms of these numbers here? Is there anything I could, recognize in terms of a pattern? Like with 7 here. So I know that's once the first, whatever number is here as a figure number, that number, the first number in the sum should be the figure number, which is 7. The middle number I know is constant at 3. My concern would be the last number. What number should that be? Well, I can do this 2 ways. I could realize, okay, they skipped the 5th and the 6th figure numbers. So I could just add 3 twice, right? I could add 3 to get the 5th figure number, then add 3 to get the 6th figure number. But is there another way to do it? Well, maybe what I could do is to look at the relationship between this figure, this number, and this number. All right. 3, for the first figure number here, I simply put 3. So maybe I'm looking at this and can think, okay, well, let's look at the other one. The same 3 here, but when there's a 2, we have 6. Okay, 3 here. When there's a 3, I have 9. Now, what's coming to my mind is a 3 times table. That's this 3, right? Times 1 gives me this 3. This 3 times 2 gives me 6. This 3 times 3 gives me 9. And this 3 times 4 gives me 12. Therefore, this 3 times 7 will give me 21. And I can get this number by adding these. 7 plus 3 is 10, and 10 plus 21 is 31. Okay, now what figure number would have been here such that I get 83? But this is a huge, well, we'll skip some numbers, right? Would have skipped some figure numbers, obviously. And then went to this. What figure number would have been here? Because no, that would have skipped some. But that figure number, whatever figure number it is, would give us a parameter of 83. Okay, this column is parameter. Well, you know what I'll do? I'll go down to the nth term, see if that can help me. Remember, whatever it is here goes here. So since n is there, then n goes here. Plus, the 3 is constant, no matter what the first is. So I'm going to put 3. And then the last number, as we notice, is the same middle number 3 multiplied by this number. For instance, 3 times 1 give us 3. 3 times, should be a 3. 3 times 2 give us 6. 3 times 3 give us 9, etc. Therefore, this 3 times n give us 3n. And when I work this out, when we work these out, we got these over here, right? So I can simplify this, therefore, to get this right here. So let's simplify. N plus 3 plus 3n. Organizing them together. N plus 3n, that's 4n plus 3. So that goes here. 4n plus 3. Is there another way I could have gotten this, though? I'm talking about for this one. Let's see. Notice something here. From 7 to 11, because notice these are consecutive numbers. So I'm dealing with 1, 2, 3, and 4. From 7 to 11, we added 4. Yeah, 7 plus 4 is 11. If we add 4 to 11, we get 15. If we add 4 to 15, we get 19. No, I'm not going to say 4 plus 19 given the next, because we skipped some numbers here. We skipped the 5th and 6th number. Okay, so we're gonna stop there. Okay. All right. Would it have worked though with the 5th and 6th number? If I add 4 twice, that's 8, and 8 plus 19. 9 plus 8 is what? I've added 4 to get 5. Well, for the fifth one, added 4 again to get a 6. Added 4 again, so this should have been 12. Not, yeah. 9 plus that is going to give you 11 and give you 31, so that's correct. But I don't want to do it that way. But we know that we add in 4 consecutively. So I'll put the 4 here as the multiplier of n. Remember, you taught that whatever we are multiplying by, the common difference, we call this the common difference, right, between the consecutive numbers. We're going to multiply it by the figure number, which we consider it to be n. All right, and then we decide whether we need to add or subtract a particular number. So let's try 4 times, let's try the first figure, number 1. 4 times 1 is simply 4, but we want 7. To get 7, we have to add 3. Okay, let's try another one. 4n plus or minus a number. Let's try the one in the figure number is 2. 4 times 2 is 8. When figure number is 2, we want 11, but we get 8. So we have to add 3. To do this, we have to add 3 again. So it must means that we are adding 3 to the 4n. Exactly what we have here. Impressive, right? Okay, so now we have gotten all that. We have gotten all the different cells, that table corrected. Which figure number will have a perimeter of 47? Well, we still have to complete this one, right? Yes, we have to complete that one. Now, notice that the formula for these guys in this column here is 4n, 4 times the figure number plus 1, plus 3. So 4 times the figure number plus 3 will give us these values. So when 4 times the figure number, whatever figure number n is, plus 3 give us 83, we can determine what the figure number is. So what we're going to do, we're going to carry this over, so it will be 4n equals 83 plus 3 goes over as minus 3. So we have 4n equals 80. What do we do next? We divide, because 4 times n, so we divide by 4. Since we're multiplying by 4, we divide by 4 to get rid of the 4. That gives 1n equals 20. You can use your calculator to check that. So the figure number here must be 20, because n is 20. n represents the figure number, and n is 20. Let's see if it makes sense. 4 times 20 plus 3. Does that give us 83? 4 times 20 is 80 plus 3. Yeah, it does. And we can fill this one out. All right. So same number goes there, 20. The repeated 3, yes. And the last number is always the middle number times the figure number. 3 times 7 is 21, for instance. 3 times 4 is 12, for instance. So 3 times 20 is 60. Let's check it out. 60 plus 20 is 80 plus 3, 83. Yeah. And let's see what they're asking us down here now. They're basically saying that which figure number will have a perimeter of 47? So 47 is somewhere between 31 and 83, right? So 47 is somewhere there. We're not sure which figure number it is though. But to get, remember, it's perimeter of 87. So this 47 here, we go into this column. All right, and to get the figure number, we use the formula 4n plus 3. So 4 times the figure number, n, plus 3 should give us 47. What is that figure number? Well, we're going to remove plus 3. To remove plus 3, we have to subtract 3 from both sides. Okay, subtracting 3 from this side leaves us with 4n. Subtract 3 from this side, let's show it. Seems as if the plus 3 went over, become minus 3. So that's 4n equals 44. Then we divide both sides by 4. 4 into 4 goes once, so that's 1 times n is n. And 4 into 44 goes 11 times. Does that make sense? So that figure number that should be here is really 11. All right, so let's check it out. 4 using the formula, right, to get the perimeter. 4 times the figure number of 11 plus 3. Let's see, 4 times 11 is 44 plus 3 is 47, the perimeter. Yeah, so that answer is which figure number? Figure number is 11. That's it.